Welcome everybody to Racer X Online. I'm Kris Keefer. That's Paul Parabinos. Welcome to England. We are at the Renthal Factory. I'm excited today. It's a big day for me. Paul, what are we doing?
Well, Kris, you are going to get to design your own handlebar bend today. So whatever sweep, width, height, whatever you want, you're going to get to go home with that handlebar and test it. We're going to show you how we make sprockets and a whole bunch of other processes here inside the factory here in Manchester.
So if you guys are techie geeks like me with handlebars, come on inside. We're going to show you how a handlebar is born, the process in which they make it, and those bars that are on your bike right now, you're going to see how it's made. So come on board. All right, as I came to Renthal, I did not know that the guys are actually going to build my own handlebar. As you guys know, I've talked about this on my show a lot, is how much I love handlebars and the whole rider aspect of the triangle. So for me, once I got word that they're going to, have my own bend, they asked me if I had any idea what I already wanted to do, and I was like, I've had this for 7 years. I already knew what I wanted to do. So what I didn't know, though, as I got here, was how involved it was to actually make a handlebar. Like, I know it's fairly difficult, but then as I was going down the process with everybody, I was like, man, it is so much more involved than I ever thought it was. So the first thing we did as we roamed the halls here at Renthal is we actually went upstairs, and we had Lewis and, of course, Paul Taylor here. They designed the bar for me, got the measurements laid out, and give us the process of how that works once you guys decide, okay, we're making a bend.
So normally with a new bar, we'll base off something existing in the range. You've got a benchmark, and then you can go 2 millimeters higher, a little bit more back sweep, a little bit wider, etc. So we got what your base was. And then when we're making a new bar, it's much easier to develop it as a 7/8 bar. So we thought that's the best starting point. So you worked with Lewis from the base bar and kind of sat together and then worked out we want to tweak, and you want a bit more back sweep than the starting bar that we came up with. And then once you've got that bar, there's 2 more challenges. We do want to make you a fat bar eventually.
Right.
So you need to make sure it's compatible with the fat bar taper and the angles and the bend dies that we use. But we also, for your test bar, need to make sure it'll work with the cross brace. So it's a bit of a compromise. If we take your ideal geometry, make sure we can bend it and put a cross brace on it, and then also make sure we can turn it into a fat bar.
So I get a lot of questions asked to me, how do you guys determine what bar bend you're going to make?
So that's normally determined by what racers want. We'll get a request from a race team, we would like an 827 but 2 degrees more back sweep, or whatever the rider wants. We'll make it for the rider if they like it, and then we think there's a market for it, we'll release that into the market, which is why our range is so varied and all the widths are slightly different, because it's nearly always derived from...
So there's no set time on what you guys are doing. It's like, hey, we're going to make a new bar on this time.
No, it's purely by, some years we'll go a few years without developing anything, some years it can be multiple in the same year.
And those measurements that you come up with are strictly from R&D purposes, race teams, stuff like that?
Yeah, 99% of the time, yeah.
Okay, so the next step we actually went and do after we sat down with you and Lewis is we went to the unicorn of Renthal, I like to call him. So a guy named Raphael, and we call him Ralph here, and very smart guy, knows a lot about handlebars. Actually, I think, and maybe you can tell me, he knows a lot about every process.
Yes, there's pretty much every machine, every process at Renthal. He's not had a little play with it sometime.
So what is his job once you guys got the bends and the measurements down? What happens with Raph?
So he needs to turn our sort of make-believe geometry, normally feedback that, no, you're being silly, you need to change this, you need to change that. Then we'll work together to make sort of a perfect shape which will still suit the rider, but also suitable for manufacturing. So we'll give him the handlebar shape that we want, make a few tweaks between ourselves, and then he will work out what the starting length for the bar will be, and then work out how to program the CNC bender in order to make the bar.
Yeah, so as you guys can see here in the video, we actually went down and he actually bent the bar for me. So there's 4 bends is what he was telling me?
Yeah.
So there's 4 bends within a bar, and that process is done with the machine. So yes. I guess what these guys are watching here on the video, what is that process?
That's technically called a rotary draw bender, CNC bender. So that you put the raw tube in, and then it will pull all 4 bends simultaneously from a CNC program to get very good repeatability.
All right, so once Barbara's pulled us into her station, she showed us a process that you guys do. It's called the heat treatment test sample station, I guess.
Yeah.
Explain what we're seeing here.
So we will complete a tensile test on the bar. So we'll grab both ends of the bar and then pull it until it snaps. So we're measuring the amount of force it takes to break the bar. With a fat bar tube, it's around 20 tons.
Wow.
So that can be then, from there we can work out the stress or the yield stress of the tube, the ultimate tensile stress, and the elongation that the tube sees before bending, which is really important for us to ensure that the bar will always bend in a crash.
What other processes go on within that station in there?
We also do fatigue testing for new products. So the fat bar that you'll get eventually, we'll before we let anyone use a product, whether it's a racer, whether it's public for sale, we'll always fatigue test the handlebar to make sure there's no issues at all. And then we can destructive test the handlebar using the process called the lateral bend, where you apply force using the same equipment that you've got to the end of the bar, and that will then, you can see how much force it takes to bend the bar to make sure that it's safe for use.
One of the stations I thought was one of my favorites, watching these new robots that you guys got. So we have 3 robots, Colin, Colette, and
Cuthbert.
Cuthbert. That must be a UK name because I've never heard that.
Yeah, so originally Colin I decided it was Colin the Cobot.
Okay.
Raf put a sticker on it, became a bit of a joke.
Yeah.
And then as the other ones have arrived at the factory, other people have named them, and it's sort of part of the ownership of the cell. The cell leader often names them now.
So we have Colin,
Yeah.
and he does the swaging. So what is swaging?
So swaging is when you form the tube from one diameter to another. So the fat bars start at 28.5 millimeters, and then we put it into the swaging machine, which has 4 dies which rotate round, and they basically, like a rotary forging process, they hammer the tube to turn it from 28.5 millimeters down to 22 millimeters. And also there's a mandrel that goes inside the tube which controls the inside diameter of it to make sure it's a repeatable process.
And the unicorn of Renthal can program all of this.
He programmed all of that, did all the sequencing, worked out the most efficient way to swage the bar, saw the bar, leave the bar to drain, then re-grip the bar whilst the next part's going, with the aim that the swaging machine never stops. The very first attempt at this, the Cobot was spinning round and really nice to watch, but the swaging machine was just sat with the door open waiting for the next part.
So oil.
There's oil going everywhere, a right mess. So after a couple of attempts and working out the best sequence, if you look now, the Cobot's going, Colin, right to the front of the swaging machine just as the door opens, and then you can run in the machine at the most efficient way you can.
Okay, so about the knurling process. Now we knurled my bar manually. We did that. You have that machine also, but you have a robot named Colette that can do all the knurling, and we videoed some of that. So what does Colette do?
So Colette's job is to knurl and eddy current bars to automate it. So previously we'd have someone standing at the eddy current tester, feeding the bars in, looking for a failure or spike in the graph, which is another test we do before we process any of our handlebars to check for internal defects. So we've now managed to automate that process, and then there's a special box which looks for a signal, and then if it's bad it puts it into a reject area. If it's good it carries on. So once Colette has eddy current tested the bar, she'll spin around, knurl it, and then put it away to continue the process.
Now the next process that I thought was unique, and I get a lot of questions asked about this, is the stamping and the grid on the handlebar. So this is paint.
Yes, we used to use a laser mark.
Okay.
But if you're using it, especially on the road, you get salt, it can corrode the handlebar. So if you use paint on the grid, it's actually a lot more hard wearing, better for the handlebar, less chance of corrosion.
It just stamps it right in. What I thought was unique about this is the tool that you guys use, it self-aligns it so it's directly straight in the middle.
Yeah, and we clock it up every day. So if you put the bar in, stamp it, turn the bar around, stamp again. If you can only see one stamp, you know it's bang in the middle of the bar.
And just for the people out there, the grid on the handlebar is not an alignment of where your bar is with the suspension on your fork. It's just an alignment where you guys would want to have a reference where you want to put your bars.
Yeah, it shows you exactly where the middle is, so you can measure left to right, and then you can work out whatever angle you want it. And then if you take the bar off, if you mark where it is on the bar or look at the grid, you know then to put the bar back on, it's in the right place. Or if you replace the bar, you can put your new bar on and get the position right first time.
Okay, so after Raph bended the bar, it goes to blasting and then anodizing.
Yeah, that's correct.
And so that once he does that, they can have the guy sit here and he can blast it. How does that process work?
So we put the bar onto a jig, hold it vertically, and then blast the bar all over. So that serves 2 benefits. It increases the fatigue life of the handlebar, and also it gives a uniform finish. So once the bar's finished and you anodize it, so it looks more aesthetically pleasing.
So after blasting, it goes to anodizing. That is offsite.
Yeah, that's offsite.
And this is when it comes to colors. I guess what people always ask me: how come they don't do more colors? Why don't they do a different color every year? Or I just always get asked about colors. So what's the reason?
Because there's only so many tanks you can have at the anodizers. So to change the tank's a big process. And the other part of it is we need to do a lot of testing to use a new colour, because the light fastness is important to us. So you could bring a colour in that's not controlled and then all the bars could fade. So we'll only bring something to market once we're confident that the colour's okay.
All right, so I went over and met Ross. Ross is the gentleman that fits up the cross braces.
Yeah.
So give us the process in which that happens.
So you take the bar, put a brace on either side of it.
I was very, very bad at this, but
You took a few attempts.
yeah.
I think we were panicking that we were broken.
Yes.
The fixtures, but
Yeah.
when you see Ross do it, he's just a natural. He just goes brace.
Yeah, so he slides each end on,
Yeah.
and then there's a machine that actually helps you push that in.
Yes, that ensures that the cross brace is parallel to the bottom of the handlebar, and then lines the braces up to make sure they're parallel to each other, and then you use a air-powered torque wrench to screw each side of the brace clamp together.
And then the bar pad goes on.
And then the bar pad
It's
goes
called
on.
the bar pad.
It's not a bar without a bar pad.
That's right. And then it goes to a final inspection. So what is involved in that?
So that's to have a final review of the anodizing process, check for any sort of marks, blemishes from there, to make sure that the pad print's correct, because no one's actually checked at that stage that the mark that's stamped onto the bar matches the pad print. And finally, it's just a last check for defects before we ship the product.
So what's crazy, there's a total of 19 steps, and we didn't cover every single step here right now, but like there's 19 steps within a 7/8 bar. And with a fat bar, there's 27 steps.
Yep.
And a fat bar obviously is more involved because of the size of the bar and
The swaging as much as anything. That's the reason why we've given you the 7/8 bar as real bar initially, because a lot easier you can do it in a day to get the geometry correct. With the swage bar, the challenge is it can take a while to get the swage geometry correct. You can then go to bend it and found out you don't like the shape of the bar or you made a mistake. Then it's back to the iteration, back to step one again.
Okay, on our second day out here, we dedicate a lot of our time to the aluminum sprocket side and twin rings, ultralights, countershaft sprockets. So there's 9 steps within this process that we shot. Give us the lowdown on the 9-step process to make a sprocket.
So when you're making a rear sprocket, we start off with an aluminium sheet and then we plasma cut it. Then from there, we machine a very tightly toleranced datum hole into the middle of it, which is then used to align the sprocket onto every other process. So from there, we cut the teeth in with a gear planer, which gives you a very accurate profile for the teeth. And using the same datum, you can then put the chamfers onto the part, put the mud grooves onto the part, and finally CNC the part to make it unique to the motorbike.
Very unique machines that I've seen here. We got a mix of older lathes, and then you got a mix of newer mills. It's a different mix here.
Yeah. So with some of the older machines, like we question every year, why are we still using this old-fashioned machine? It's from 1920s, 1930s.
Oh, that old.
Yeah, some of them are pre-war. But then when you look into it, the footprint's very small. It's really accurate, really repeatable. And you can put a stack of about 30 sprockets onto it and it'll machine them all in one go. And if you're doing that on a CNC machine, there's a lot of feeding parts on, feeding parts off. You'll probably end up taking longer than putting them into the gear planer. Once it's running, the operator can walk off and do something else for a while.
A question I get asked a lot, I was talking to Reese about this earlier, was the countershaft sprocket. It's directional, right? When I get a new sprocket, I take my old one off, and sometimes I don't pay attention, and I get people, hey, how does the Renthal countershaft sprocket go on? Which way does it go on? There's one flange side. So they're not marked, and they're not marked for a reason, I was told. So because sometimes they supersede to other models.
Yes, so probably 95% of the time, the recess goes on the outside or where we stamp the part number.
Okay.
However, there are a few models out there where it can go on one model one way and then you can reverse it for another model the other way. So we can never really make the statement that always put the part number out. But 99% of the time, that's correct.
Well, that's critical for us dummies out there that are novice mechanics.
Yeah. The best thing to do is try and take a picture of it. Don't get too giddy before you take the sprocket off.
Yes.
Just see which way around it came off the bike.
Renthal just introduced their new lock-on grip. Obviously, Renthal is huge in the grip world in motocross and bicycles right now. So what am I holding? What is this? It's a little bit slimy, but give us the rundown on what this is.
So this is a rapid prototype overmold for a grip. So when we were developing the lock-on grips, we wanted ways to make sure that we had the best pattern possible. If you were to make a tool for the grip, it's extremely expensive and takes a long time to make. And then you could plow all that money into it, run a trial and go, no, that diamond's too big, that diameter's too big, that waffle's the wrong shape, the waffle's too long. So we've invested in a rapid prototype machine that can print the hard preforms that actually make ride test parts from, but you can also change the material that goes into the machine to make this here. And this is a soft overmold for a grip. So we can then trial and we can do, if we ever want to change and do a larger diameter grip, we can make a ride test sample, get some feedback and see if we're wasting our time investing in the tooling.
Another interesting tidbit that I found out that you guys actually make your own tooling, some of these inserts that go in here. So what's that all about?
So as I was just saying, the cost of the tooling's really high. So if you want to run a trial, we can actually machine our own inserts on the CNC machines that regularly make cycle parts. So we can 5-axis mill the inserts and then send them off-site to our grip manufacturing facility and then get the grips made, run some trials, and then if they're popular enough, we can then look at making steel inserts for them.
Something we're not going to cover a lot here. I'm going to do this on my Keefer Tested podcast, but how many employees does Renthal have? And there's quite a bit of them that have been here over 10 years. So the turnover rate is non-existent.
Yeah.
So unlike in America, where the turnover rate is high in a lot of businesses, you guys have people that have been here a long time, very passionate people. So how many employees does Renthal have?
So we've probably got about 95 at the moment. We vary between into about 80. When we were really busy after COVID, we were quite a bit over 100 employees. But as you were saying, yeah, we've got a core workforce. There's quite a few people that have been here for 30 years.
Longest tenure here?
30 years, there's quite a few people.
Yeah. I met a couple people, 31 years, 33 years, and very passionate people, take pride in their work. We were a pain in their butt today and yesterday, and everyone was smiling. They were happy to have us. So it was really cool. And I thought I just want to mention that because it's rare that I see that many people in one spot that's been over 10-year mark in a business. So after packaging, handlebars are done, packaged, they go over the warehouse. I went over there, lots of products that are stored over there. So what's that process a little bit?
So once the products are finished, we will build the stock for the distributor orders into the warehouse. And then when the order's complete, we can then pick the whole thing in one lot and then ship it out to the distributors.
Yeah, there's 3 levels. So you got lots of product in there. So yeah, it's a very, for me, it's a lot of intricacies through here. It's just not, building the parts. You got shipping the parts. There's a lot of things moving here. And you said how many employees again? 90?
It's about 95
employees. So a little bit for me, like I was a shipper back in the day. So when I get over there, I'm like, I know how much work actually goes over. People think, oh, the work's done, but it's really not.
No, there's a lot of stock building. I think it's because we sell many different chain wheels in different colours. So there's probably 600 different chain wheels that we sell. So if a distributor's ordering a few of everything, we've then got to make everything in a reasonable size batch in the manufacturing building and then bring it over, anodize it, and then put it into the warehouse ready to pick for the distributors.
Okay guys, that's a wrap here from the Renthal Factory in Manchester. To say that I am excited about having my own KK bend bar is an understatement. You guys saw the process from start to finish. Hopefully you guys like that. I'm going to take this thing home and ride with it, and super excited. And don't forget, there's going to be more information up on my website, keeferinctesting.com. We're going to have a podcast. And I just want to sit here and thank everybody from the Renthal Factory for showing us around. Hopefully you guys learned something about the bar process, sprockets, grips. They do so much, and they're a big part of our industry and our sport. So thank you to the guys at Renthal. And don't forget, subscribe, 12 issues, RacerX magazine, other stuff within the magazine that you can't see here online. And we'll see you on the next video.